Now, we will connect these stats according to their time sequence. First, after the gripper opens, the telescopic rod extends for material pickup, followed by the slider moving downward. When the slider reaches the position, the gripper closes. At this point, we need to adjust the time for closing. The default closing time for the gripper is 0.35 seconds, but this is unstable for real operations. We will increase it to 1.5 seconds. Click OK. After closing, the slider resets to lift the material. The telescopic rod retracts, and the rotating rod rotates 90 degrees. Once the rod reaches its position, the telescopic rod extends again. After the rod reaches its position, the slider moves down. After the slider reaches its position, place the material. The material placement time is originally set to 0.35 seconds, but we will change it to 0.75 seconds to allow for a longer placement time. After placing the material, the slider resets. The rotating rod resets, and the conveyor restarts. The conveyor starts running, and the object source generates new material, completing one cycle. Next, we preview the material pickup process for the first object. The first material source's pickup process works normally. Now, we will rotate the turntable by 60 degrees, 120 degrees, 180 degrees, 240 degrees, and 300 degrees to fill the 6 material slots. Create a new operation. Select the turntable position control as the physics object. Set the position to rotate by 60 degrees. Set the condition for rotation as the detection of material at 0 degrees. The 0 degree sensor detects material after the first slot is filled. Name the sequence turntable 60 degrees. And click OK to complete the first position setting. For the next 4 rotations, we will copy and paste the sequence to quickly set up the remaining positions. Then edit them one by one. After the first 60-degree rotation, the second rotation will be 120 degrees. Its condition will be triggered and the 60-degree sensor detects no material or material. For the third position, set it to 180 degrees. Triggered and the 120 degree sensor detects material in the material slot. Follow the same steps for the remaining positions. The turntable will rotate to 240 degrees, triggered, and the 180 degrees sensor detects material in the slot. Click OK. Finally, the turntable will rotate to the 300-degree position. Completing the setup for all positions. Next, we review the rotation angles: 60 degrees, 120 degrees, 180 degrees, 240 degrees, and 300 degrees. By reviewing the time required for each rotation, we can determine that there might be a risk of the turntable reversing due to the different rotation times. We will check the position control settings and notice that it currently selects the shortest path, which might cause the turntable to reverse. To prevent this, we will select Track Multiple Circles under the Angle Path option. Click OK. To complete all the element setups. Click play to observe whether the movement matches the actual material pickup process on the production line. Upon observation, we can see that the movement sequence aligns with the real process. Finally, let's review what we learned in this lesson. 1. We analyzed the components of the simple handling production line and determined the types and quantities of joints required for its movement. 2. We created the necessary motion units and joints for the mechanism's operation. 3. We developed sensors, actuators, and grippers, and implemented speed and position control to prepare for motion simulation. 4. We created operations to complete time-sequenced motion simulations. Finally, please complete the following exercises as homework and practice more after class. That concludes today's lesson. See you in the next class.